Hello class 9. Today in this video we are going to study about the graphical our chapter is motion in one dimension, and under this we are going to study a very important topic regarding that is a graphical representation of rectilinear motion. Dear student, we know that rectilinear means a motion which is always travels in a straight line. Rectilinear means straight. So we are going to study the graphs regarding that which are in moving in a straight path. Okay, so we will discuss under this there are some graphs, like the displacement time graph, velocity time graph, and acceleration time graph. All these are graph we will study one by one, and all these graph as the displacement time graph, and we can also say that the velocity time graph, acceleration time graph. We will study just all these graphs just gives the rectilinear motion. Okay, and we are under that we are studying today. We are going to study about the displacement time graph. Dear student, we know that displacement time graph always gives the just velocity. Okay, if someone asks you what is the displacement time graph gives, means what is the result of the displacement time graph, we will obviously say that the displacement time graph always gives the velocity of the particle. Okay, so under this we will discuss the graphs one by one. So the first one is the case that when one thing it is also clear that this displacement time graph always gives the velocity. And how velocity can be find out? Velocity can be find out by just finding out the slope. And the slope of the graph will be what? The just value of the y-axis divided by the value of the x-axis. We will just find out the slope by drawing the perpendiculars on the x-axis and the y-axis, and with that we will able to find out the slope. So slope of this graph, displacement time graph, always just gives the velocity. Okay, velocity of the body or the particle which is moving. Okay, so the first case here is when displacement time graph is parallel to time axis. Suppose a displacement is just plotted on the y-axis, displacement is just plotted on the y-axis, and time is plotted on the x-axis. So in this case, what will happen when the body is just traveling, or we can say the displacement time graph is parallel to time axis? What is the criteria here we are getting here? Just see here that with increasing time, means here is time is increasing. Okay, 1 2 in the displacement is just it is, suppose a displacement time graph is parallel to time axis. Here with the graph we are just getting here that in every particular case the time is increasing 1 2 3 4, but the just displacement is same. Okay, in every particular second it is just covering 8 meter. Okay, 8 meter displacement is just measured in meter. So in every 2 seconds it just again it is constant here, that is 8. In next third second it is at the same position, that is 8 meter. So what we are getting from this graph? The particle is moving here in every second? No, it is remain at the one place. So with this conclusion we have just get an idea that when the displacement time graph is parallel to time axis, the body is not moving, the body is stationary at some particular point. Okay, the body is stationary, or in other words we can say that the body is stationary. Means every particular second, increasing of every particular second, the particle is always at the same position, that is 8 meter. Okay, if you are just plotting this on the y-axis. So with this regarding, we can say that when the displacement time graph is parallel to time axis, that the body is in stationary position, means the condition of the body doesn't change, it remains at one place, that is, it is stationary, it is not moving. Okay, and what will happen, the second case we are just going to assume here, when this is the displacement time graph. Displacement is plotted on the y-axis and time is plotted on the x-axis, and in every particular second the displacement is also increasing here. In 1 second is covering 5 meter, in 2 seconds is covering 10 kilometer, 3 seconds covering 15 kilometer, and so on. So what we are getting here, we are getting here when the displacement time graph is a straight line. Okay, this graph is a straight line but not parallel to time axis, means when the displacement time graph is just a straight line and not parallel to time axis, then we can say that it is covering equal distances in equal interval of time. Let's see here that in 1 second it is covering 5, in 2 seconds it is covering 10 meter, in 3 seconds consequently it is just covering 15. So there is a equal interval, there is equal interval, it covers equal interval in equal interval of time, equal distances in equal interval of time. Okay, so in this case the body is moving uniformly. Okay, uniform motion. Okay, or we can find out that uniform velocity means the velocity here is uniform, although we are getting that displacement time graph always gives the velocity of the body, and here in this case we are getting what kind of velocity, that is uniform velocity, because it covers equal distances in equal interval of time. Okay, or we can also say that the displacement is proportional to time. Whatever the rate of displacement is just increasing, in that rate the time is also increasing. So we can also say that the displacement is directly proportional to time. Okay, and what is the conclusion we are getting from this graph? The conclusion we are getting from this graph is we are getting the uniform velocity. Okay, and how the velocity, just a uniform velocity can be found out? By finding the slope. Okay, by finding the slope, easily we can able to find out the slope. Okay, suppose we have to find out the just a uniform velocity up to this point to this point. Suppose we are considering here A, this is B, so we will find out the slope here. So what will be the slope? Means we can determine it at delta x is a y-axis and delta time is x-axis. So up to this, suppose it is A, it is B, the delta x would be 15 minus 10 equal to 5 upon 3 minus 2 equal to 1, meaning 5 by 1. Okay, so velocity will be 5 meter per second. So in this case we will able to find out the uniform velocity. Okay, now here just see here that here is a condition that what will happen. In the first case we have just studied that displacement time graph is parallel to time axis, but in this case what is happening here, in the displacement time graph, the graph is parallel to displacement. Just think, student, just think, it is quite unnatural case that it is possible that in every 3 seconds we can just cover 2 meter, 4 meter, 6 meter, and so on. It is possible in the same 3 minute or in the same 3 second. We can cover different displacements we can cover. It is quite impossible because it will take some time when we will change our directions or we will change our just displacement. It will take some time. In particular 3 seconds we can't just travel different displacements. Okay, so with this graph, we will able to determine, we will just getting one conclusion, then when the displacement time graph is parallel to displacement, what will happen, it is quite impossible that in the same particular 3 seconds we can't cover different displacements. So this case is quite impossible. Okay, this case is quite impossible.